Yeah, so welcome everyone. Good afternoon. So this is the sixth instance of our monthly webinar, Defeat the Hackers. And today we have Natascha, who will be talking to us about how we can secure our ABAP, like custom ABAP secure code, and also how a secure lifecycle process can be built around it so that your whatever code you are custom writing is also secure. And just to add, we have a Q&A box which is available. Please feel free to ask any questions if you have in the middle. Also, you can use the chat box. We will be monitoring it. Today we have less participants. So yeah, in case whoever is listening to the recordings also, if you have any questions, you can reach out to us, me or Mukesh. We will be sharing the email IDs at the end. Yeah, with that, I will hand over to Natascha. Over to you, Natascha.
Great. Thanks very much for the introduction.
Yeah, I will stop sharing. Yeah.
Great. Okay, let me just share my screen as well. So there we are. Great. Yes, hello everyone. So from myself. So yes, I'm Natascha Lalor. I'm from the COE Security and Governance here in Dublin, in Ireland. So I'm doing security for quite a long time, and it's getting, of course, more and more important for customers to secure, their crown jewels, their main business systems. One of the areas I'm working a lot with is basically the custom code security. So I know one of my colleagues here had already done a very good session on the code vulnerability analyzer. So this session is more about the processes around the code vulnerability analyzer. So how do you use it? Where do you use it? When? And what other things to keep in mind when securing your custom code. So the main title is basically the Secure Software Development LiveCycle. So what are the processes around these? Good, so let me just can you see all the screen exactly? So thanks for the poll. So first of all is the question, so have you heard the previous session, or do you know already about this code vulnerability analyzer, or is it a complete new topic to you? So it depends on how deep I have to go through the initial slides from Peter Barker, or is it already known? So if you can answer the question on the poll.
I have one response, so I think it'll be better if everyone could actually respond to the poll so that the content then becomes more relevant. So right now there is a 50-50, Natascha.
Okay, good. Good, so I will be semi-fast going through these. So for that one person who answered with yes, they know this tool. Can you put up maybe the second poll already, just to see if they indeed using the static code analyzer, so or any static code analyzer or the code vulnerability analyzer. So and for this participant who answered with yes, are you using a product like this or code vulnerability analyzer already, or you don't? So yeah, if you can just answer that.
So the response is no.
Okay. Okay, great. Good. Thanks very much. Good. Okay, so then I know how or what to look out for. So yes, then we start then in general with introduction, of course. The core businesses that you're using with your custom code, of course, it's growing and growing and complex. That what we are seeing, the complexities is very, very large. This is one of the problems to keep your custom code secure. When you look at, it also changes all the complexity of these. The other hand, yes, usually the main the main priority usually on custom code is, of course, the performance and, of course, the stability of these. So security is always kind of an afterthought in custom code. So But yeah, why do we need the security there? Well, I think it's with everything in first you've seen a similar slides like that before, even with the hardening of systems, but also it's the same for the custom code. So of course if there are vulnerabilities that are getting misused in your custom code in the applications, of course it's a whole thing of the negative publicity of the brand damage. So like the recent, well, it was a ransomware attack on Garmin, if you heard about that. Well, it's you lose sort of the trust in the brand. A lot of negative publications now about Garmin. Would he ever use Garmin if it's so unreliable? They're getting attacked. God knows what data may be leaked by this. So that would, of course, will cause lost revenue, because maybe you think, or the customers think twice of buying your product if you as a company are not secure and maybe leaking data or it's unreliable. So like Garmin, they were basically shut down for about 4 days at least. So this is not a good thing, of course. So after an attack, you usually have to rebuild the system. So this is not a good idea. So I know in a lot of countries there are now legal consequences. So especially here in Europe, where I'm living, you have the GDPR. So we have legal consequences on data leaks of any information that may be leaked, and even penalties. So the GDPR has like a high penalty to pay it if you're not adhering to these rules. So I think any country has similar kind of rules to that. Good. So yeah, what are these typical vulnerabilities that are found with the static code analysis, or that we are trying to prevent in the custom code? One of these, or most of these, are kind of injection vulnerabilities. So what does that mean? So injection is basically putting something into the code or into the SQL or even the command prompt and put something malicious into that. So in the SQL injection, classically, that would be something like, yeah, changing the whole where clause, or by entering something or injecting something like a salary variable. So for example, you have this this application. It's usually handling, for example, HR kind of data, and as well, it has somewhere the salary, but usually you can't change the salary, so it's no salary field. However, if the attacker knows this variable salary, they can inject salary equals, I don't know, 2,000 or something, and then this value will be used. So I think we have that typical example. I think Peter Barker showed it before already. And this is similar to the ABAP code injection. So you could potentially inject malicious code into the program because it's dynamically created. And operating system command injections, the same thing. You could inject something like a telnet command or something else malicious into it, and many more things. So these are the things we trying to fight on the application level or in the custom code. So the other thing is, of course, the backdoors. This is, of course, malicious if some developer, some malicious developer creating backdoors that he or she could misuse afterwards. Other things are missing authorization checks, or basically authorization checks being, well, ignored, so missing action. So we've seen that a lot of times, that it's been done by mistake or been forgotten what to do with that. Web-based exploits, yeah, with info or anything, that is another thing. And of course, non-compliance to any of these regulations, like the GDPR, for example. So the problem that there is, and this is a very, yeah, very critical one, because yes, first of all, you have to understand all these threats that I just mentioned. So, and how do they fit in with the infrastructure? So it takes really only the one flaw in your application to, yeah, to be misused. So, but you must basically secure everything, and that is really the problem. Yeah, and there's not enough to just rely on the infrastructure or on the underlying kind of security controls you may have, because sometimes they may not work, or it's maybe an internal attack even. So it doesn't matter then if you have the infrastructure secured. Good. Just have this following little example here. So normally, and this is basically the problem, usually when you're designing the application, you usually think it's been designed that it's been used as intended, right? So when you see these typical numbers, you would think, okay, maybe the following, the continuation of these would be maybe something like, yeah, the 12, 14, 16, or maybe other more adventurous ones. But usually you have some kind of integer value that just following these lines. So that's what you expect when you create your application. Yeah, the end user of this application will automatically enter the right value. So the problem is that it doesn't work that way, right? So unfortunately, you have these attackers, even if it's an internal attack or external, they will enter something else to either break the application or, as we said, inserting something. So you see here this r equals 1, 1 equals 1. This is basically a typical SQL injection. What exactly this does is basically this statement is always true. So 1 is always equals 1, right? So if you inject that into a where clause, it will output the whole value of your table. So again, this is maybe not as you intended, because you're only fetching maybe one value or something, but you don't want to output all the values, especially if it's maybe sensitive or confidential data. So how can we intervene this, or what can we do to prevent these? So the one thing is, of course, the code vulnerability analyzer, and of course for non-ABAP is the Supportify by Micro Focus. But let's focus on the ABAP first. So the code vulnerability analyzer is basically SAST or SAST, so static code testing. So what that means regarding, or in the opposite, you have the dynamic testing. So as you've seen, you need all of these in this circle, right? So the SAST, or the static code analyzer, is only this small little quarter of everything that you really need to cover. So to do the full test coverage, we actually need all of these here. So basically a manual code review, because again, the static code analyzer, like the code vulnerability analyzer from SAP, it's only testing, yeah, the typical vulnerabilities that we just seen, like SQL injection, authorization check missing, few of the backdoor thing, but it does not replace a manual code review. So for a principle of going through the code manually. And certainly some things can't be caught by a static code test. You still need a dynamic code test, for example, like logical errors. So of course, any static code check or even a manual code review would not detect any logical errors that may lead to misuse or to vulnerabilities in your code. So overall, basically, you have to keep in mind to use all of these mechanisms or controls to secure your custom code or to do meaningful testing. So yes, I think that was the slide that you possibly seen as well by my colleague Peter Barker. So let's quickly run through it. Of course, it's one of the best practice, because of course SAP is using this product all the time. So what basically is this? So it's again, these are the slides that we've seen from Peter. So there's one person who's seen this, you will possibly remember. If it's new to you, unfortunately, we don't have that much time to cover this, but it's basically the code vulnerability analyzer is part of the ABAP Test Cockpit. So which is very nice, because you can use all the features that are coming with ABAP Test Cockpit. So for example, one of them that I would know finds is exemption handling. So this would be the same as you would be used to from the ABAP Test Cockpit. So you can raise exemptions, have been approved or not. So that's the normal process as per ATC. You can even control your transport management. So that is one of the great features in the ABAP Test Cockpit, that you can say, okay, so for this bunch of security checks, we like to stop our transport if we have priority 1 checks failing on this. So, or if it finds any vulnerabilities of priority 1, you'd like to stop your transports, for example. So this is all part of these ABAP Test Cockpit. So it's fully integrated into this, which is nice, really. You don't need to learn any new tools or anything like that. It's just a new check variant, basically, of your ABAP Test Cockpit. Good, so the rules per se, so that we go already a little bit more into the into these processes around it. So of course you have the developer who is developing on the ABAP test ABAP workbench. So in this case, then we have some quality expert or quality management then who runs these checks. Yeah, that's where it comes already then to our processes. So how often would you run these checks then? And this is basically the one point, so I'm not sure if Peter went into it, but this is basically more or less what I want to discuss in this session. So what are the processes around this? So usually we have a queue gate, I guess, something similar to that, where you usually scan all your code. So usually it's done for performance and syntax checks and so on. So there where we would see also the security checks to be run. So usually you have also for the CVA checks should be also part of these normal quality gates that you scan it. And as I said, you could have, or you see the check results that could be emailed to the responsible developer. Again, the developer could then raise exemptions saying this is a false positive or this has been taken care of already. I'm not sure, but whatever exemption he may think, or it's a false positive maybe or something. And then again, as the ATC, as I mentioned already, it's been quite tightly linked to the transport management. So it can then be decided, should we go ahead with the transport or should we stop because there's still priority 1, for example, security vulnerabilities present at the moment. So that's already talking a little bit about the process of when to use and how to use it. So as I said, integrated in your usual static tests that you're running at the queue gates before the transport. Good, yes. So that was actually the person seen it already, possibly the typical SQL injection. So again, you have a salary field here, or variable. So what we expect is basically just a street change, for example. What is happening here is the SQL injection saying salary is 1,500. So this is here the SQL injection that we're injecting here at the input level. So what this program does is then basically setting these values. So yes, the street has been changed to X, Y, Z, but also the salary field. So even it's not asking or doesn't have the user input for the salary field, it's here injected into the code. So that is a classic SQL injection. Yes, and of course it's been set in here. So how this code analysis works, and so that is one of the big differences between the code inspector and the code vulnerability analyzer. It's actually checking the whole flow of the program. So where does this value come from? So yes, there is this input field, and that's where actually the attack happened. It doesn't happen directly at this where clause, but it happened beforehand at the input field. So, and then of course, it's that such expression here that made it possible to set this salary variable in the end. And of course, that's the data flow here in between this input field and then in the end, that statement here. Right, so this is a nice thing that the code vulnerability analyzer is basically checking where is the source coming from, where is that value coming from actually. And as we are all with security, we shouldn't really trust anything, right? We shouldn't trust the input fields, as I said with one of the very first slides. you shouldn't expect always that the end user is really using this input as intended. You have to really think out of the box what could happen. So in this case, yes, there was a code injection entered. In this case, the salary field. Good, so how do we fix this? So we fix it here at the set expression level. So we do here these input validation about these quotation marks that are caused this SQL injection to ignore this, right? So that is basically how to solve this in this case. So this is the other nice thing in the code vulnerability analyzer you get in the help text of these findings. You click basically on these findings, so in this case SQL injection, and it already comes up with a proposal of how to solve this. So in this case, use this BAPI here to do the input validation with basically ignoring the quotes. Of course, we do need this for integer variables because yeah, it's only accepted the integer, not a string. Just very quickly on news and ABAP Test Cockpit. This is more ABAP Test Cockpit rather than the actual code vulnerability analyzer. It's basically that you can now have, well, I would say from 7.5.2 onwards, you have now the availability of saying you can use a centralized ABAP Test Cockpit or code vulnerability analyzer to scan remote systems. So that's actually quite nice. So you don't have to configure the ABAP Test Cockpit for each of your development system. You do that centrally on one system that is, well, higher than 7.5.1. I would say it's stable from 7.5.2 onwards. The 7.5.1, you still have a lot of prerequisite nodes to enter. So I would say 7.5.2, 7.5.3 is one of the better choices. But yes, so that's a relatively new thing to execute these checks basically on a centralized level. And of course, ABAP Test Cockpit, it ties into the solution manager. So one thing I really like to highlight is the code, custom code lifecycle management here. We will talk about this a little bit more because what I like to discuss here is what I see a lot of times when we are scanning custom code. So that is one of the services that we are offering for max attention and active attention customers, that we scan the code. We are able to enable this code vulnerability analyzer license for the number of days the service is on. So usually between 2 and 10 days, depending on the customer needs. So what we can do there is basically scanning these codes. Usually we scan through the whole custom code namespace. But the problem is that sometimes that there's quite redundant code found. So I would nearly say in some cases it's up to 50% of the vulnerabilities found overall are basically found in old redundant code. So especially maybe back then, no one really paid much attention to security, or it was basically being forgotten, or the code was never wasn't really looked at anymore because it's an old application that nobody uses anymore. Well, what is the problem with that? Well, the issue is there still that even unused applications, they still can be misused. So if they have vulnerabilities, of course, you can still misuse these. So that's why custom code lifecycle management is very important in this case, to basically highlight, okay, what of this code has not been used maybe for a year. So usually you then do a project like that with enabling things like the UPL for, well, we say at least a year or so. So basically trying to get the quarter or year's end kind of, kind of mechanism in. So anything that has to be run maybe only once a year, and basically log over the year to see, okay, what applications are really used, what objects are really being used, and anything that hasn't been used in the time frame to disable it, because that's everything about security, right? You just disable everything unused because, again, things can be still misused. But good, so that is the one project that I like you to think about when thinking about custom code, that, again, old code could basically entail any vulnerabilities that could be misused. And of course, with Fortify, you can extract the data as well from ATC. Good. Yes, and this is exactly what I was mentioning earlier on. So when, or if you have this project of securing your custom code, then really think about as well the quantity of your custom code. So basically, is there anything redundant? Is there anything that is maybe a really old application that hasn't been used for the last 3-4 years? We see that quite a lot, that when we show the results of the scan to the customers, that they say, well, hey, these are all really old applications. The developers aren't even with us anymore. That is really, really old. But yes, it is still very vulnerable code. It is still critical to leave the code there. So either you have to fix it, and of course it's more, how you say, more expensive, or it takes more resources to fix this code rather than retire it. So that is the point 3 here. So again, use UPL to switch it on. It's not having too much footprint even, so it doesn't impact the performance of the system. So you can just run it on your productive system to see what is actually being used. And yes, custom code lifecycle management can basically show, it can show also the delta. So once you run the code vulnerability analyzer, you can have the delta between them to see, okay, these findings or these vulnerabilities are not used, or it's in an unused program. So we're starting already to talk a little bit about what to do or how to secure your code. So yes, that's actually the next poll, or the last poll that I wanted to ask. So how many of you are having kind of a documentation, or basically any kind of development guidelines? So if you can bring up the last poll, the poll 3, please. Yes, I don't see the poll. Bibin, are you still there? Ah, there it is. Perfect. Yes. So yes. So are you using any kind of handbooks or guidelines already for your developers? And would it use, or does it have already some guidelines on security in there? So for example, you shouldn't use, or you always have to do authorization check. You always have to check against the authorization, something like that, and prevent any SQL injection where possible, do input validation, anything like that. Do you have that already in place? Okay.
Sorry, I was on mute.
Mhm.
Yeah, I think, Natascha, we have 7 responses. 6 people are saying no, and 1 person is saying yes. Yeah, so
Okay.
I think the answer is no.
Okay, very good. So that is actually, let's go then to the next slide. Thanks very much. So indeed, and this is actually, so this is basically the Secure Software Development Lifecycle. And what I think it's very important from this is to see, we have to really start quite early in the development to think about security. So this is actually very important. So this is basically the Secure Software Development Lifecycle, or SSDL, that SAP is using at the moment. So it starts really with the security awareness, so with security training of the developers. Because as you've seen from the very first slide that we've seen, developers usually, or even the designer, the colleagues who are designing the application, they really assume always that the end users will use the program as intended, or your application. And you have to think a little bit more out of the box, or the developers or the designer of this application, they have to think out of the box. They have to think, okay, can we actually trust this input? So with security, we do not trust anything, right? Or when you think of even directory traversal, can we actually really trust that the end user will put in the right file name or the correct path? So these are directory traversals. So you could potentially read in any file if you try to exploit this vulnerability, or you even overwrite something, right? So this is actually really a really dangerous thing. So you have to always think, can we trust these things? Can we trust that user input? Or if you fetch things from RFC, can we actually trust this other source? Or can we trust maybe that the RFC is really secure? Because a lot of attacks happen in RFC, right? So this is always the thing. So this awareness has to be there, so that zero trust, I would nearly say, and this has to be in the mind of the developers, or of course, and the people who are designing this application. The other thing that SAP is doing, and we will talk about this in a minute, is the threat model. So threat modeling is basically done already in this early start, where you prepare or where you're designing the application. So while security testing, well, is this again something you need to plan? You need to know how to do security testing, and of course secure programming. So how do we avoid these vulnerabilities in the first place? So in SAP, we do have a full curriculum that the developer has to perform before even allowed to be developing. So, and that means basically they had done a course of secure programming. So as I said, do input validation of everything. Anywhere where you have a user input, either for the SQL or for the file name or something like that, you have to validate this input. So that would be the first rule, for example, in secure programming. But yes, they have to know how to do the authorization check properly, because we've seen that a lot of time that yes, there is an authorization check, but then no consequences to that. So in programming terms, no super C if clause behind it. So it's just saying authorization check for this object, but then nothing. So nothing's happening in that. And that's happening a lot of times, and this is basically just lack of knowledge, I guess, or maybe yeah, they weren't aware, or it's, again, this is basically the awareness, or there should be some kind of training to observe for the developers. The other thing, well, this is more, I'm not sure how it is in India. As I said, here in Europe, we are very strict with this personal data or handling of personal data. So with a GDPR. So if the application here is handling, or even in your case, if you have maybe data subjects within Europe, you also have to follow the GDPR, right? So if you do any business with Europe, or any of your vendors, customers, or so, would be residing in Europe, and the data is being processed of these data subjects, I would say. So then you need to have this data protection and privacy kind of knowledge. So that is then basically the risk assessment afterwards. So that is the thing you need to then know, this threat modeling. So I will go into that into detail, but threat modeling is just a really great way to find the risk and to evaluate the risk of your application. So for example, you know you have a user input. So how that's a risk, you know, because we do not trust this, as we said. So then that goes into the next step, into the planning then, right? So if you know we have to somehow validate this input, you have basically these requirements, or you have to adapt to these requirements or certain controls that you need. The other thing is, for example, with SNC, or yeah, have SNC with your RFC. Basically, if you can trust maybe, or you don't want to trust the normal unencrypted RFC connection, you might need SNC, you might need encryption. So that would be security control here. So that's why this risk assessment automatically comes into the planning. So you know what the requirements would be in your application. The other thing is, as I mentioned, the privacy. If you're handling personal information of a European data subject, you need to also do this privacy impact assessment. There are certain rules for this as well, but that is more related to GDPR. But from these, as I mentioned, if you have things like the SNC, or you maybe say, okay, well, we are uploading documents from the internet, we shouldn't trust this at all, of course. You maybe need something like a virus checker or something. So that would be control. But from there, you know exactly what to test, right? So you can do the testing on if these controls are really working. You know what I mean? So for example, if you say you have this input validation, the test would be, okay, the dynamic test, okay, the tester should really check, can I do these, can I input like the SQL injection, for example, or if I know I need to do a virus check, or I need to encrypt. So these are the things you can test for later on. So you can create basically this test plan from the results of your threat model. So that's why I think it's so important to start, first of all, to learn what is a threat model and use it as a risk assessment. And then from there, you know what requirements and control you need, but also in simple ways, what to test for. So of course, then this is secure development. So again, secure programming, you should do a review. So how often to test? So that is one question I'm always getting, or how often should we scan if you have the code vulnerability analyzer, for example? Yes, scan theoretically as soon as you write code. So even at the end of the working day of a developer, they should scan it. But very late is at the queue gate, but then there might be a mad rush if there are vulnerabilities found and they have to be fixed, because usually there are deadlines as well, right? So it's maybe then already a bit too late, but that's why it should start quite early in the development lifecycle to do the static tests as well. But very late is at the queue gate before you transport, right? So, and then there's of course also the dynamic testing. So you possibly do dynamic testing like the acceptance testing or regression testing. But yes, think of the security controls and as well, just also use what you learned from the threat model before. So can I test anything for any of the security controls that are indeed working as intended? So a lot of customers, they do independent security assessment, which that means it's basically a penetration test from a third party. And of course, you have to have some kind of response plan in place. So that is already here during the planning. You just put it into place. You just execute this once your application is released. So what that means, so for example, in SAP, we have a huge security response team. Of course, it's understandable. We have them even in any time zone. So what it means is basically if our customers suddenly report the security issues that we can deal with in their time zone. So basically 24 hours, more or less, that we can cover any incidences that are arising. But I mean, in a smaller scale, it means basically that you have to have something in place like a ticketing system. If you possibly have that already, but also something somehow that the end user can report any security issues with that application. So we had that already a couple of times that our customers would tell us, oh, one of our employees actually found a vulnerability in our own custom code, and if you can support fixing these, or maybe help them to find more vulnerabilities that there may be in the coding. So we do see that customers are using this, and so end users should have the possibility or the ability to enter or to report any security incidences with that application. And of course, you have to have some kind of plan in place of how to deal with that. So that's the main area we want to talk about. I very quickly go into the threat model because I don't think there's much known about what this is. So I will very briefly cover this before we go to the Q&A session. So yes, what is it? So that's the SAP definition. What is a threat modeling? It's a systematic approach to uncover security threats at design time. And this is a thing, it's done during the design time to reach a secure design, right? So that's why you use it quite early on in the stage. So that's just the general definition of it. So what are we doing in SAP? So threat modeling, it's nothing that SAP invented. It's been there mainly actually by Microsoft, and they have this really great module because it's using all the three most powerful threat models together to because again, we can have the misuse cases. I like that quite a lot. The brainstorming, I think it's also good. So any unknown or any best practices. I personally don't like attack trees, but I know that's been usually actually been done in university. So if you're studying cybersecurity, it's usually you're doing the attack trees. I personally don't like them, but again, we use basically all of it. That's called the Stride model. So that's what Microsoft is using, and that is what SAP is using as well. So just as an example. But again, I would say like whatever you're most comfortable with. If you're studied cybersecurity in university and you've done the attack trees and you like them, of course, go ahead with the attack trees. If not, do the brainstorming or a mixture of everything. That's what SAP is doing. But good, so what does STRIDE mean? What does it stand for? So spoofing, I'm just gonna put these up as well. So yeah, spoofing, of course, it's impersonating someone. So that's basically part of the authentication. The tampering, so modifying anything, so basically the data integrity. Information or repudiation is, of course, so claiming that you have performed any or not performed any action rather. Information disclosure is, of course, the confidentiality. And denial of service, of course, is like what you have with any kind of web attacks, usually the DOS attacks, basically. So that would be the availability and elevation of privileges. That's the authorization. So someone gains more access than they possibly should have. So yes, so coming back to these, so I think these are the really security basics. So the CIA principle, so confidentiality, integrity, availability. So usually when talking to customers, they mainly are afraid of the integrity of the systems because, yeah, can you trust your system? Can you trust your data? So that is quite scary. So especially with the SQL injection, right? So you can potentially change any data in your system, or even with the directory traversal, you can overwrite files theoretically. So can you actually trust the integrity of your system? So with the GDPR, for example, it's saying the confidentiality, especially of personal information, is very important. But of course, if you have any confidential data on your system, any highly sensitive data, of course, the confidentiality is the most thing you're afraid of. I have to say availability is the less scariest one, because usually you have the high availability kind of systems, right? So you usually have failovers and so on. So availability, DOS attacks, and you have load balancers that are usually protecting you against these DOS attacks. Maybe if you're using sub GUI scripting, that can be a worry that you could overload the system with something. But generally, I think availability is the least concerns of most customers that I talk to. Of course, as I said, authentication. So is that really the right person on the system? And then no repudiation. Of course, that's one of the main concerns as well. So, but how do we do the threat modeling? So first, you have to ask yourself, okay, what are the assets of that particular system or of that application, of the data that you're handling? So is it really highly confidential data? Is it very sensitive data? Or is it just, well, no real significant data at all? So from there, you have to sort of see what would be the risk. How bad would that be if this data leaks, for example, or if this data gets somehow being manipulated? So that's what it means by assets. So what is basically, what do you have on that system? What is it processing usually? Is it an HR system, or is it your main ERP system? So in this case, it's of course, the assets are very important. Also just some little internal sandbox maybe that doesn't have any data. So who are the threat actors? So who would be the threat actor? So in your application, who is it aimed for? Is it the end users? Is it even external users? Or is it just maybe an internal tool for your basis employees, for the admins maybe? So who are the actual actors? Who are the actual users? Or who could using or misusing this application? And then of course the vectors. So how is the exploit being done? Or how can the exploit being done? So is it either via a user interface? So that would be the actual attack vector. So you have to look at your application. Are we relying on the user input or on an RFC, for example? So that would be basically the attack vector. So how is the application being misused? So with these, you have to really think, as I said, in the planning of your application, you have to ask yourself these questions here. And from there, you basically can judge first of all, the likelihood. So how difficult is that to attack? So for example, we go again from your user interface. Well, you could mitigate it. That's the next thing then. So the likelihood, yeah, you have the input, user input. It's quite likely that you could yeah, misuses. And if the assets are being high, so the impact is quite high and the likelihood is quite high, you end up with a high risk on this, right? So that's how you use this. So then you have to decide, okay, do I mitigate it? So as I said, for example, mitigation of user input, user interface is of course input validation, right? So you would basically know straight away, okay, the security control that I need to implement in my application is any kind of input validation. The other thing is, if you're saying, okay, well, the threat actors are just internal, so we're not really that concerned about internal attacks. The assets, there's not much on the system either that is could be misused or that could be interesting. The vector, well, okay, it ends up maybe here still in the low category or maybe in the medium here. You could maybe just accept the risk. So it's good to know about the risk, but yeah, we can also just go and say, okay, we accept these. So that is basically the very basic threat model that I wanted to discuss. So I see we are nearly running out of time here. And I want to, of course, open for any question and answers on that, or any questions and giving you answers, of course. Yes, so I would say I would end here with my presentation. I hope you found it useful. And yes, let me know if you have any questions. Are there any questions in the chat, maybe?
Natascha, I think there is one question in the Q&A box. The question is from Anil Kumar. Is there any security threat through SAP GUI?
Yes, good that you asked that. And indeed, so the SAP GUI itself, it needs to be patched regularly as well. So I think you had my colleague von Buchholz already also in one of your webinars. He talked about the patching or security patching. Of course, there are security patches also for SAP GUI, because there are some vulnerabilities known already that are mitigated by patching it. The other thing is SAP GUI scripting. So if you have it enabled, it is quite a vulnerability, because usually you use it for mass inputs. I know a lot of customers are doing that. It helps, of course, to enter like a bulk of data. But of course, the misuse, it is risky, of course, to do this. Yeah, indeed. So yes, that there is a risk from that. So any best practice tips for outsourcing ABAP development? So yes, if you're outsourcing the development, like a lot of customers, they do that. They don't have any more in-house developments. That's why I was asking about the security guide, kind of handbook. So you have to really write in your security guides, but usually you have some kind of development handbook for the developers. So that should be really clear that you also include the security in there, so that you either say, okay, well, please ensure you always have to have a authority check or authorization check in there, ensure that you mitigate the risk of input validation and so on. So yes, so you
Natascha,
use,
this is Mukesh here. So is there a sample handbook that you have that we use internally, which you can show at least the main headings of what that development handbook should contain?
We don't, unfortunately. Well, we have one, of course, but no, and unfortunately, I can't share that.
But if you can just share, what are some of the things that should be included in that handbook?
So what I've seen from customers who are using that quite well or doing this quite well is, yes, basically you have a list of, when I go back at the slides, so basically what, can I go back to the, let me just see if I can go back to the previous slides of, well, one of the earlier slides of the typical injections, right, that I wanted to show. Going back here, let's see. These, yeah, all these injection things. So you can basically say, very simply, avoid all the SQL injection, avoid all cross-site scripting, ensure there's no ABAP injection possible, and so on, right? So you could do all these vulnerabilities as a as a negative, or as a, ensures there's no SQL injection, ensures there's no cross-site scripting, which leaves it then up to the developer to ensure that they use, or if you have user input, use input validation. Don't trust any input. Don't if there is an external document being uploaded, ensure it's checked for viruses, and if it's sensitive data, ensure encryption is used. Well, things like that you basically mention any of these. There is basically the secure development, I think, that is available somewhere. So you can basically use all these forms in the handbook of saying avoid all these typical exploits here or vulnerabilities here, or be more clear and say make sure that, or ensure any input is validated, any user input is validated, ensure that if handling sensitive information, that encryption is used, things like that we see in the handbook, and ensure that you're doing the authorization check properly. Yeah, and then react to that. so that what we've seen, so that is, as I said, there's authorization check, but then there's no handling of this exception, that there's no authorization. So the reaction isn't there, or the authorization check is completely missing. So yeah, ensure that there are authorization check, and then ensure there is a action or reaction to this as well. So basically use the negative form of these vulnerabilities here, that what you see in most of these guides or handbooks. Yeah.
Yeah, Natascha, I think if you have time, I know that you have another meeting to get to. So if you have time, there is one more question from the chat. Is Code Inspector available in SAP? I'm not sure if it was already covered in the later presentation. It came like half an hour before.
So Code Inspector is this part of any SAP system, yeah. And I have to go to the next meeting here. So, sorry.
Yeah.
Yes. So,
okay. So if anybody has any more questions, please reach out to us. I will be sharing the contacts later. Thank you, Natascha, for the great presentation. Yeah, probably. Yeah, you can log off and go to the next meeting.
You can also post your questions on the WhatsApp chat or email us when you receive the registration email. So thank you so much.
Yes, thanks very much, and thanks for hosting.
Take care.
Thank you, Natascha. Bye. Yeah.
Goodbye.
So.